So this is the demo for an S&S interpreter. So right here, we just have a simple test case. It's in the int main function. We initialize, say for array int a of 3. We have a for loop. And inside the for loop, we have a of I equals I, and then int x is equal to a of 2, and then returns x at the end. So I'm just going to run it for you. So when we run it, we are met with the AST tree or parse tree. It shows you basically the flow of this test case, and it labels each scope of which it's in. So for example, I'll just go through one. The for loop, as you can see here, it shows the var dec I, which is in here, the assignment, which is 0. And then inside the for loop, we have the array access, which shows the identifier I and I. At the bottom, after we run it, it also shows the tag code, and the tag code just basically prints out what the test case is doing. So what I'm gonna test right now is just some syntax errors for you. So first, we're going to take out a simple semicolon and see what it does. So after we run it, we can see that it detects there is a syntax error. It does say on line 3, even though it is line 2, that's just how the compiler is. But the important thing is it does identify that there is an error. Um, so yes, it can detect a semicolon error. Next, we're going to, let's say we put in like random letters on accident and we run it. Again, it shows there is a syntax error in terminal. It detects that. Next, we're going to take out a bracket for the for loop. And as you can see here, it says parsing failed and knows that the bracket is missing and it's not in the correct syntax. And then lastly, we're going to take out like, for example, a semicolon in the for loop and see what happens. And last test, it shows that there's a syntax error because it knows there's no semicolon here. And then we're just going to quickly look at this part of the code. So this part of the code, it just lists out all the tokens, the literals, operators, identifiers, etc. And so if in the test case anywhere there's, for example, if there's an operator that isn't here and it doesn't detect that, then it'll prompt up an error. And uh, same with like if there's a int or something else that isn't here, it'll prompt up an error. And so this was all for the syntax portion of the demo. Shanika will guide you through the semantics portion.
Okay, so looking at the semantics, the second half of the S&S compiler, this is going to take care of all the initializations. So we know that the array here is being initialized for all three elements. So let's say we only initialize the first few, but we are taking care of the last one, or we want that value. So when we run it this way, we see that the AST does get printed out because the way that it works is it'll run through the AST, the syntax, and then it'll check for all these semantic conditions. And in this case, array A is initialized at index 2 and we're trying to return it. So let's fix that. This doesn't only just apply to arrays, it can apply for values here as well, where we have a general variable that we want to return. This will also prompt a initialization issue because at this point in time, it's not with any values, so it can give us garbage values, and that would be a problem. So to bring this back, this does not mean we always have to use the safe array declaration. This supports the same functionality in a normal int, so you can use any character array that you normally would, and it'll still do the initializations correctly for that respective value and ensure that everything's returned properly. Last but not least, let's say we only initialize it up to 2, which will give us this error. But say for the last value of the last part on this array, I wanted to give it a value 4 instead. This will be okay because as long as the assignment is initialized, it will work through everything correctly. It's just ensure that every assignment is done for every declaration. And to quickly show where all of that happens is in the main semantic code, we can see that the variable declaration is going to be within the table for everything that we find. And all the nodes or the different parts of the declaration, if that comes to a main assignment, as we've shown in the presentation from the AST, that assignment is going to have the identifier, the int literal, or the array access, taking the declared variable and giving it a value. And as long as it's declared and it's initialized, when it revisits that node, it will ensure that if that isn't within the table the next time it sees it, there's going to be an error at that line, and those are the errors we see when we have initialized variables. But that is for the demo for the S&S C interpreter. Thank you for watching.
Thank you for watching.